Dear students, how are you? I hope that everybody is doing great. Here we are doing another video. So today we are going to talk about section 6.2 of our student book that is related to three important points. First one is central angle, the second one is arc, and the third one is chord. So the first one, central angle, that we actually studied in chapter 5.2, we had a clear definition for central angle. We said that central angle is an angle whose vertex is the center of the circle. So look at this, the vertex of our angle, our central angle, it is exactly the center of our circle. And basically the side of our central angles are two radius of the circle. The second one and the third one are arc and chord. Imagine that here we have actually three different circles. Well, I just showed the arc with a red line. So look, that red line that is a part of the circle, it is on the circumference of the circle, we call it arc. Okay, so here is an arc, that is an arc, here is arc, and that small one can be arc 2. And here the arc from A to B, it is also an arc. And the arc, guys, that one is a special one. Imagine that here is the center, which is O. And the center is O. That arc that across from it will make a semicircle, which means it will divide the circle into two equal parts. Okay? So if a full circle is 360 degrees, a semicircle is half of it, which is 180 degrees. That's all about central angle and arc. And that line that will join that point to this point, that's the arc across from it, we call it chord. Okay? So here is a chord, and that one is also a chord. And it has a special name that we call it the diameter. Okay? The line that goes through the center of the circle and will divide the circle into two equal parts, we call it diameter. And it is always equal to twice of the radius. So up to now, we studied the central angle, the arc, and the chord. So here we are going to be familiar with some important points regarding these three matters. The first thing is, a full circle is 360 degrees, that we already mentioned it. So a full circle is 360 degrees. It might come as a gap, as a question, in ijtimai question. If we divide a circle, okay, if we divide a circle, but into n congruent parts, okay, here in this next slide it's much more clear. That one, here there is a question. We divide a circle into 4 equal parts, okay, so our n is 4. So each central angle will be equal to 360 over n. Okay? Imagine that we will divide a circle into 3 congruent parts. So in that case, each central angle's measure is going to be 360 divided by 3, which is 120 degrees. And that's what will actually be discussed about it a lot on chapter 5. And the last and the most important point regarding these three points is always central angle is equal to chord, and both of them are equal to arc at the same time. So imagine that we have a circle and it gave us the arc, the given arc is equal to 30 degrees. So it might ask for the chord that across from it, or the central angles. Since we know that point, okay, that's important hint, so we central angle is also 30 degrees. So remember guys, central angle is equal to chord and both of them are equal to arc. The last and the very important part of that section that the examiner are really interested to bring questions from this part of that section said that in a circle, imagine that we have a circle, okay? If the diameter of the if the diameter or sorry I have this or if the diameter or the radius was perpendicular on a chord, then it will bisect the chord and the arc. So let's come to here and more elaborate it here. So look, that is the diameter, that orange line, okay? And as you can see, it is perpendicular on this chord, okay? So according to this point, it said that if the diameter is perpendicular on the chord, so it will bisect. What does bisect mean, sir? Bisect means that line will bisect, will divide that line into two equal parts, which means that if that part is 5 centimeters, the other one is going to be 5 centimeters too. And I hope it will be clear to you guys. What about the radius? The radius has the same story. The radius is perpendicular on the chord, so it will divide the chord into two equal parts, which means if that part is 3, the other part is going to be 3 as well. Okay, so let's deal with some question, and I hope that it will be much more clear to everybody. Here, that question I was wanting that if I read the question regarding the first part, which means that imagine that we have got a circle. Alright, and we divide that circle into 4 congruent parts. So find the measure of this given arc. Remember that we said each central angle is equal to 360 divided by n, and that n displays the equal arcs. Here we have 4 equal parts, so 360 divided by 4 will be 90 degrees. It tells us that each central angle is equal to 90 degrees. Remember the important point that I said, central angle is equal to the arc across from it. So automatically the arc is going to be 90 degrees. So let's see what kind of arc is required us to find. The arc AD, that arc is one of the 4 equal arcs, and it is equal to 90 degrees because we found that the measure of each congruent arc is equal to 90 degrees. And the next one is the arc BCD. From B, we will come to D. How many equal arcs it will take? So it will take 2 congruent arcs. So it means 90 plus 90, 180 degrees. Okay guys, so look, one more time, that arc up to C is equal to 90 degrees, and from C to D is equal to 90 degrees. So 90 plus 90, 180 degrees. Next question came from that part that I told you the examiner are really interested, and they have a great desire to bring questions from this part. And it says, find the measure of RQ. So RQ is a chord. That one. So, by the way, I forgot to mention these 2 angles are equal to each other. Alright? So if these 2 angles are equal to each other, which means if they are central angle, the arc across from them are also congruent with each other. So it means AY minus A should be equal to 6Y. Because, guys, QR is the chord or the arc. By the way, central angle is equal to the chord and both of them are equal to the arc. So here, since these 2 central angles are equal to each other, the chords are going to be congruent to each other as well. It means Q R is equal to R S. So what is the measure of QR? 8y minus 8. What is the measure of RS? 6y. So they are equal. Remember in the previous section we said that we will move the smaller variable to the bigger one. And the number to one side. So 8y minus 6y. It will become minus 6y because we change the sign of the term. And we said whenever we do that, automatically the sign will change. And here is negative 8, so it will become positive 8. So 8y minus 6y is going to be 2y equal to 8. Divide both sides by 2, divide both sides by 2, and y equal to 4. Or, guys, you don't need to do this step, because I always said that the smart student will ask themselves that 2 multiplied by 1 is equal to 8. 4. And still it's not the end. We need to find RQ. So RQ is equal to 8y minus 8. 8y minus 8. And we got the value of y is equal to 4. So 8 multiplied by 4 minus 8. 8 multiplied by 4, 32. Minus 8, 24. Next question. Let's see what kind of question. Okay, there is another one more question regarding that matter. And right here we have a radius which is perpendicular on this chord. Remember we said if it is perpendicular, so this side, this part is equal to that part. So let's see the question what we asked about. If AO is equal to 3, if that part is equal to 3, and the radius is equal to 5, so the radius, guys, are you with it? Divide the distance from A to C is the radius? Absolutely yes. So it is equal to 5. So find the measure of BC. We need to find the measure of this chord. So first of all, let's find that part and plus itself, so it will give us the measure of BC. So for that question, guys, we need to remember a very important theorem, which is Pythagorean theorem in section 6.1. It says, Pythagorean theorem says, if we have a right angle, and the measure of these three sides are, let's say, x, y, z. So the Pythagorean theorem says x squared plus y squared is equal to z squared always. So based on this theorem, let's just follow that theorem in order to get that OC. So in our right triangle we have 3 squared plus OC squared is equal to the hypotenuse squared, which is 5 squared. So 3 squared is equal to 9 plus OC squared is equal to 25. Again, a simple equation. So move the number to one side. So OC squared is equal to 25 minus 9. 25 minus 9 is equal to 16 OC squared. What is the inverse operation of square? I told my students that it is square root. So square root will keep square and only OC will remain. So what is the square root of 16? 4. So that part which is OC is equal to 4. What about BO? BO is equal to OC. So it's going to be 4 too. So 4 and 4. Right now, what is the measure of BC? B is equal to 4 plus 4, which is 8. And that is the answer of the question. Next question, let's see whether we have a question or not. Yes, one more question regarding to that part of that section. And again, we have a radius, which is perpendicular on a chord. And it shows us that these two parts are equal, because that small line will tell us that these two parts are equal to each other. So find what? Find PQ. Again, we need to find that part, which is the chord PQ. So we know the Pythagorean theorem. We said that this one is x, y, and z. So x squared plus y squared is equal to z squared. Excellent. So let's use that idea, that theorem for that question and find, I think it's P. Yes. So first of all, PO is equal to 6. So 6 squared plus the other leg, which is TQ, it's unknown, so we need to get it, is equal to the hypotenuse. Okay, is equal to 10 squared. So 6 squared is equal to 36 plus TQ squared equal to 10 squared, 100. Wait, so move the number to the number side. 36 will come together and it will become negative. So 100 minus 36, it will give us 64 equal to TQ squared. Remember the inverse operation because we are looking for, guys, we are looking for TQ without the square. How can we remove this square? By taking the inverse operation. What is the inverse operation of square? Square root. And this square root will give the square, and TQ is equal to, what is the square root of 64? 8. Excellent. So we got TQ as 8, and we know that PT is equal to 8. Because they are congruent. That radius will bisect the chord into 3 equal parts according to the previous point that we mentioned. So 8 plus 8, 16. That is why PQ is equal to 16. And that is the answer of the question. And we don't have any other question. I hope that the lesson was understandable to everybody.